All right, so what we have here in the box is an RDI Instruments Workhorse ADCP. The ADCP stands...
Just a second, make sure I am... Continue. Here.
Start over?
No, start over, yeah.
No. So what we're going to talk to you about today is the RDI Instruments ADCP. The ADCP stands for Acoustic Doppler Current Profiler. And what it allows us to do is get a vertical profile of water velocities above the instrument if it's mounted on the bottom looking up, or below the instrument if it's mounted from the boat looking down. Depending on the software that's programmed into the instrument, can also collect wave data as well. So with an ADCP properly deployed, you can collect surface elevation, so mean water level. You can collect directional wave information, and you can collect vertical profile of the water velocity. If you are able to deploy these in an array, you can really get a really comprehensive view of what's going on in your coastal environment, coastal or ocean environment. All right, so for instance, we have 3 of these ADCPs, not this particular one, but very similar, deployed in the Banana River right now, one near each of the entrances to that water body, and we're using them in order to better understand the flow within that restricted water body. All right, so let's crack open the box and see what's inside. Remember, the A stands for acoustic, so we're going to have some sensors that can send and receive acoustic signals. All right, so the first thing we see some cables for communicating. There's some more cables for communicating here. This particular instrument is it's dated, but still works fine. The particular last calibration of this instrument was about 10 years ago from the factory, but of course we recalibrate these before we deploy them out in the field. So the instrument itself is a housing that in the base of the housing is the internal battery, and then of course we have the sensor head, and so we have the sensor head, and then immediately behind that is the actual electronics behind the system. So we notice we have 4 acoustic heads on the sensor, and they're numbered 1, 2, 3, 4, and these are the actual kind of the working part. These send and receive the acoustic signals that the instrument uses to collect all its data. On the bottom we have the plug for the communication cable. Of course, because these are deployed underwater, we need a plug that's waterproof to protect the plug while it's in the water. And so we get that off, and we'll just put this back in the case now, so it doesn't roll away from us. This particular workhorse costs it's about a $25,000 piece of equipment here, so you need to be especially careful with how we handle these things. The last thing we want to do is drop it or do any damage to it. It'd be very expensive to try and fix. But yet at the same time, we're just going to take these things and put them out in the water for a while and hope we don't lose them, right? Okay, so this particular instrument, again, we have the configuration summary. Has the date of the configuration, who the customer is. This is on loan from the Naval Surface Warfare Center, and there's some important information on here that we'll need when we plug it into the computer. Clearly, the frequency is one of the important pieces of information. So it's broadcasting and receiving at 1200 kilohertz. Depth rating. So for us, typically we're not anywhere near that 200 meter limit. We're typically deploying these in coastal waters. It tells you what sensors are installed. So here you got to pay attention. Even though it's depth rated to 200 meters, pressure rating is at 50 meters. So we don't want to really go beyond that. This particular instrument does have the water profile and wave gauge acquisition. So this one is waves capable. And so we'll be deploying, this is one that we would want to deploy in the coastal ocean or the open lagoon where we might be interested in collecting wave data. On the communication side, this baud rate's very important. We got to make sure we match that baud rate when we plug it, hook it up to the computer. All right, so let's get it hooked up and see what happens. Okay, so we're going to get this thing plugged in. We'll take the cable, match the pins up, plug that in. And just to make sure it doesn't come out while we're programming, we'll loop it over. And then we'll go ahead and stand it up. Okay. Now, even though there is an internal battery, if you're unsure of the condition of that battery, it's good to go ahead and power the system while we have it plugged into the computer. And so there's this additional cable to power the system here. So plug that in. Now each ADCP is going to be slightly different in how it's cabled. Since this is an older instrument, it's got this external power. Most of the newer instruments don't have that feature. And I might have to pause it for a second. Okay, again, in order to have this older technology compatible with newer technology, we just have a dongle here. It goes from serial to USB. So we'll make that conversion, and then bring this over and connect it to the computer. All right. Now we've pre-installed the software. You can go online to the Teledyne Instruments website and download their deployment software. It's called WinSC, located here. So we'll open that up. And the first thing it does is pops a welcome screen where it allows you to configure for new deployment, test, recover data, or display data, or just begin a terminal session. Typically, if you're not bringing it back in from the field, what you're going to want to do is configure a new deployment, assuming that someone's already brought it back, cleaned the data off, and the instrument's been put away, ready for reuse. So what we'll do is we'll go in and configure for a new deployment, and we'll just click OK. And one thing I want to do before that is you can come to settings, and you want to make sure that first off you've detected the instrument. So we detected that this is plugged into this USB port, which is COM9 on this computer. But here, if you recall, we talked about the baud rate, parity, and stop bits. Well, from the configuration summary, again, you want to make sure that the baud rate and parity match up with what's on this sheet. And so they do. So I'll click OK now. And then we can go to File and go back and click on New Deployment. This will close the currently open deployment. Do we want to do that? Sure. Let's say yes. Okay. All right, now we have a really nice graphical interface, and it's going to take us step by step through the deployment and help us plan and program the instrument. So we'll click the next button. And the first thing you do is select which instrument do you have. We have the Workhorse Sentinel. And click next. And then, again, from the configuration summary, we know that this is a 1200 kilohertz instrument, so we'll click 1200. Next. We have one battery pack. Of course, before you deploy that, you'll want to install a new battery pack. You don't ever want to reuse an old battery pack because you don't, you're taking them out and testing them, but you're unsure of the battery life there. Ocean, we're going to be deploying this in the ocean. And again, how are you going to deploy it? We will be maybe using this as a waves gauge. So bottom mounted, looking up, and we have these ADCP recorder card installed. It's the 1200 kilohertz, and it's the Sentinel. So I think we're good there. So the first thing, or the next thing that comes up is the depth that we're going to be operating in. So you need to, of course, understand where you're going to be deploying this. Typically, we're deploying it in the coastal waters. If we're in the lagoon, it's going to be, there's no way we're going to meet 10 meters or 33 feet of water depth. If you're up at the port, then definitely you could hit that 10 to 14 meter range. So know the water depth that you're operating in. It's critical. So we'll go with 10 meters here.
What's your minimum?
The minimum depth, well, you have a blanking distance, and what is the blanking distance on this?
It's like
thing?
40 centimeters.
40 centimeters?
Something like that. I don't know about this unit, but that's good.
That's about 20 to 40 centimeters. So you really need the, okay. So the minimum depth for deployment is kind of the height from the seabed on which the instrument is resting to the sensor head. So the instrument has to, of course, be underwater in that water depth, and that's going to be a function of how you mount it and what your mounting frame is. And then, of course, on top of this, there's a certain distance above this instrument where it's unable to record data. That's called the blanking distance, and that's typically 20 to 40 centimeters. So we need to be, we need to be at least in a water depth that's 20 to 40 centimeters above the sensor head when the sensor is deployed on the bottom. We currently have one of our newer ADCPs deployed in a water depth that's about 1.2 meters, so about 4 foot deep. The sensor head sits about a foot up off the bottom, and it's looking up, and we get good current data on that and water elevation data. There's a good meter of water above the sensor head. All right, so then we need to select what the vertical resolution is going to be. How many, what the cell size is. So what you're able to do is split up the water column above your sensor head into individual cells, and at each cell the sensor is going to record velocity in the X, Y, and Z. And so the visual here helps you kind of understand what it is that you're programming. If we have, if we're in 10 meters of water and we want the cell size to be half a meter, see if I can. It's not letting me change that. Oh, it says what it will be. I thought you could tell it how many.
You should be able to tell at a distance of the bins. Is that what you're trying to do?
Yeah, but it's, I guess we're not there yet. Okay, so we'll rewind a bit. So we've set the depth range. So the next page here just kind of shows you how many depth measurements are going to be taken and the actual depth of each cell. And here the depth of each cell is going to be about 35 centimeters. So you have cells of 35 centimeters stacked from the head of the sensor up to the surface. Okay. We have internal memory, and so that's where the data is going to be stored to as it records. And then we want to talk about how do we program the wave sampling. Because the wave, in order to record the wave data, there has to do very high frequency sampling. It can become very data intensive. So we typically sample for waves in bursts. And so we're going to do 20-minute wave bursts and do them every 60 minutes.
It's also a function of your battery power, right?
It's a function of how much memory you have and how much battery power you have. Yeah, absolutely. How many? So since we're doing, okay, and this is going to be for the water profile. So if we're doing waves in bursts, we're going to do 3 water profile measurements every hour, and they're going to be 20 minutes. They're going to be 20 minutes apart. So on the previous slide, we do the wave gauge timing. We set that up, and then here we set how many water profile measurements we do. We'll do 3 per hour, and then move on. How long is it going to be deployed? Again, the length of deployment is a function of battery power and memory. You can, and it is recommended that if you're going to try and deploy these for extended periods of time, you can get an external battery pack. The instruments we have deployed right now in the lagoon, each of them have external battery to help prolong the life. And then on our newest ADCP, I just upgraded the memory to 3 gigabytes, so that really allows us to leave that instrument out recording for 90 to 120 days. That's really a function of battery life at that point. Okay, so we'll set this up for a 30-day anticipated deployment. And then it's going to tell you you've successfully gone through all of their steps. And so what we'll then do is we'll continue with the deployment wizard, and we'll start checking the instrument itself. So we now get to the deployment plan window. Again, these are all of the properties that we just set using their wizard. You can come in here and modify them if you so desire. One thing is going to be important is the salinity. So because it's acoustic, everything is done based on sound signals, and since the speed of sound is governed by water density, water properties like salinity and temperature are important. And so if you know ahead of time what the salinity and approximate average temperature are out at that location, you can go ahead and pre-program that in at this stage. Otherwise, a lot of the instruments now come with their own temperature and salinity capabilities, or you can co-deploy a salinity gauge along with your ADCP, and then you can post-process the data afterwards and make those speed of sound adjustments. So we're going to go with this. One thing to check is, first cell range, last cell range, max range, and so that's just how many cells. Again, if we're deploying in 10 meters of water, we'll be, we're well within that range. If the water level should increase for some reason due to storm surge, then we're fine, because the instrument will be able to still manage in that depth range. You can look at advanced settings. In the advanced settings, you can set up again the salinity, magnetic variation, temperature, and transducer depth, the duration of deployment. You can adjust the wave setup here, so you can really go back and readjust all of the settings. And in the expert range, again, this is where you can set up that blanking distance, where here it's 44 centimeters. So, and you shouldn't really need to come into here. It is good to know what that blanking distance is, though, especially if you're working in shallow water depths. It also allows you to know just how close to the bottom you can get a good reading. If you're really trying to get near bottom velocities, this is not the instrument for that. That you need there's a whole another set of instruments that are downward looking to really get that near bottom, near bed flow. Okay, so once this is good, we can close this out, and then the next step is to keep going through the deployment wizard. You set the clock. Typically you want to sync the instrument clock with the same clock of the computer that you're going to be programming, onloading and offloading the data. That way everything is kind of uniform from pre-deployment to post-deployment. So we've set the clock. The next is to verify the compass. So this is a tricky but important step, and it sure is handy if you have a Lazy Susan type spinning table, which our colleague here is going to come in and deploy. One of our students who's working with us on the ADCP project for the lagoon flow. I'm going to place the instrument on the table. Make sure cord management here gets tricky as you're spinning things and rotating. The cord can get caught up very easily. Clicking next, and you just kind of follow the commands on the screen. So we're going to estimate the compass error. Press any key to start. Okay, rotate the unit in a plane until all data samples are acquired. So as he's rotating around, you can see it's going through all of the different directions. Processing the data. And total error of 9.2 degrees.
That's a lot.
That's a rather large error.
I think.
Compass error, depending on where you calibrate it, if you're around a lot of electronics and a lot of conducting materials, you can really have some some issues with getting your compass calibrated. So what we'll do is, so you can press D for details. Let's see. Okay, so let's see. Let's try hit press for return. So we're going to go back and redo the compass calibration. Okay. And again, we'll hit any key and slowly rotate. There, 5.7 degrees. So we increased our accuracy by 4 degrees, or we reduced our error by 4 degrees. Okay, so again, you can load this program on a laptop, perform these in the field if you need to, but we'll move on. So then there's a set of pre-deployment tests that kind of test to make sure the ADCP is ready to go. So we'll click next here, and then again we're following the commands on the screen. And if you can follow along, you kind of see that they're kind of just running through all of these different parameters and checking them that the instrument is set up right. You know, here we've got our blanking distance, 44 centimeters. That coincides with what we saw on the setup. Press any key to continue. Just checking those. Okay, press any key to continue. All right, I was checking the memory. Recognizing the PC card, that we have one card to be recording to. Okay, so now it's displaying the actual readings from the instrument now. It's displaying the heading, pitch, roll, up, down. It's pointing up. Ambient temperature and pressure has been calibrated to a gauge pressure here. We can adjust the heading by rotating, and it's picking up what we want it to be picking up, so we press any key. And now we have a beam, the actual beam test, so we got to do a rub test here. So we find beam 1, again located on the side are the numbers. That's a 1, and we rub beam 1. There's beam 1, right? Yeah. So beam 1 and 2 have passed. We'll rub beam 3 now. It's this guy. It's a pass, and beam 4 is opposite that. Sometimes they're tricky, but all 4 beams passed. Power's down again. And then we can zero the pressure sensor.
That'd be something you want to do on site, right?
So zeroing the pressure sensor is a bit tricky, because when these things are recording the mean water level, they're recording it as a pressure signal. And when you submerge your instrument, it not only has the pressure of the water above it, but it also has the pressure of the atmosphere. And when you have the most interesting events, like waves and surges, is when you have atmospheric anomalies, like low pressure fronts and storms. And so this is measuring the total pressure of everything above it, water and atmosphere. So what you'll want to do is, if you zero the pressure sensor it's a good idea to note what the pressure is that you're zeroing it to, right? So what is the atmospheric pressure at the time you zero the sensor? Once you record that, then you can go to either you can co-locate a pressure gauge near somewhere on the beach near where the sensor is, or you can go to a local weather station, the closest weather station nearby, and use that atmospheric pressure reading to correct your data in post-processing. This is it's a fundamental issue that you need to be aware of, and the more you control for that at this stage, the easier it will be when it comes time to post-process. So we'll go ahead and zero it out. We'll record the ambient pressure here when we do that, and set. And then the next step is to erase any data that's on the recorder, and we'll go ahead and erase recorder data. Click next. And the final step is to press the next button to start deployment. You can check here. Remember, every time you send a command to the instrument, it shows up on the screen, so you can make sure that the right commands are being set. Okay, and now we're going to name the deployment before continuing. Yes. And we'll just call this test 2. Test 2. Okay. And so you can watch along as it starts ramping up and checking all of the different programs that it needs to run on board. Now it's going. I don't know if you can hear, but the instrument itself is beeping, letting you know that it's ready, and we want to disconnect from the computer and click OK. And it's been successfully configured. Okay.